Hello, all. My name is Krish Nayak, and I am super excited to announce this amazing crash course on RAG, that is Retrieval Augmented Generation. In this specific crash course, it will be somewhere around 2.5 to 3 hours, but we are going to discuss everything that is related to RAG completely from scratch. We'll be talking about the entire pipeline from data ingestion to retrieval pipeline to output generation, how to use LLM models, how to use embedding models in this. Along with this, what should be the right strategy of using chunkings and many more things, right? So we will be deep diving into both the theoretical understanding along with the practical implementation. And we will initially go ahead step by step. We'll start with the basic implementation. And then as we go ahead in the advanced section, we'll also implement the modular coding, right? The main aim of the modular coding is to link the entire pipeline in a way so that you should be able to understand how RAG actually works and also implement it in your company use cases. Let me tell you one very important thing. 90% of the use cases that are currently being worked in all the companies are specifically related to RAG. So this crash course will be an amazing one for you, all of you. We'll keep a simple like target of 1000. Try to complete it as soon as possible, and we'll also keep a like target to some comments target of 500. So please try to complete it, and yes, go ahead and enjoy this particular crash course. Thank you. So this is a simple definition that I've put up over here. And in this definition, first of all, we'll try to understand RAG. Okay. So first of all, let's go through the definition and then I will give you a brief idea what exactly RAG is all about. So here you can clearly see that RAG is the process of optimizing the output of a large language model. Okay. So it references an authoritative knowledge base outside of its training data set source before get generating a response. LLMs are trained on vast volume of data, as we all know, and use billions of parameters to generally original output for tasks like question answering, translating, and completing sentences. RAG extends the already powerful capabilities of LLM to specific domain or an organizational internal knowledge base, all without the need to retrain the model. Okay. It is cost-effective approach to improve LLM output, so it's relevant, accurate, and useful in various contexts. So this is just a basic definition. You can refer to this particular definition. So guys, now let's go ahead and understand about RAG. So let's consider that I have a generative AI application. And as you all know, in a generative AI application, usually, let's say that I have an LLM. So this is my LLM. Now, usually, whenever we have a LLM, what happens is that let's consider that I have a user. A user is asking a query. So this is my query from the user. And before it is sent to the LLM, we do add a prompt, right? We do add a prompt. And this prompt is just like an instruction to the LLM, like how the LLM should work. Okay. And then based on this, we actually get an output. Now, this is a simple generative AI application wherein the LLM is used to generate the content. Okay. Generate the content. So obviously, by using this specific technique, we give a query and this LLM, you know that it is being trained with billions of data. Okay. Different kind of data that is available in the internet. And based on this, it will be able to generate the output. One of the disadvantage of this, let me talk about the disadvantage of this particular approach. As you know that every LLM that is trained, it will be trained for a specific set of data. So let's say right now it is 31st August. Okay, 31st August. Let's say this is my LLM model and this is basically GPT-5, which is the recent model from OpenAI. Now, as you know that when this model was launched, this model may be trained with data till 1st August. Okay. So this LLM will not have any idea what has basically happened in the current world between 1st to 31st August, right? And let's say if I go ahead and ask a specific question to the LLM, which is between these specific dates for any kind of events, the LLM will start hallucinating. So one of the major disadvantages of only using the LLM is that it will hallucinate. Okay. When we say hallucinating, what does this basically mean? It means that even though it does not have the knowledge what has happened between 1st August to 31st August, any events, even though we ask any question, the LLM will try to generate its own answer because it does not want to look like a fool. Okay, that is the best example. It does not want to look like a fool, so it will try to generate some answers and it will make sure that it will show you an answer that you may also have to believe it. That is how it will be written, in terms of the output that we get. So usually this condition is basically called as hallucinating. Okay, so this is one of the major disadvantage. The second disadvantage that you have, so let's say that I'm using this LLM, and this LLM has been trained with huge amount of data. Now what happens is that I'm running a startup, let's say. Now in my startup, I'm solving a specific use case and I have some data, which again, I need to use this particular data along with my LLM. Okay. So let's say that I have some other data like, you know, um, policies, policies of my company. I have HR policies of my company. I have finance policies, and these policies all will not be available it will not be available publicly because it is my startup. So this all data has been protected. Now I also want to use this specific data and probably create a chatbot. Okay. Now, how do I do this? Now, one way is that many people will say, hey, Krish, we can take this particular data and we can fine tune the model, right? We can simply fine tune the model. Yes, this is a very good solution. But understand, fine tuning a model is a very expensive process, very tedious process because this LLM, whichever LLM we are using, it has billions of parameters. And tweaking this billions of parameters usually takes a lot of time, right? So obviously, this is a solution, but this is a very expensive solution. Okay. Now, do we have any other way? Any other way? And remember, these all policies and these all data will also keep on getting updated as we run the startup, right? So every time we cannot just go ahead and fine tune it. Like every day we will not fine tune it, right? So we should try to find out a solution. Like how do we prevent this? So this can again be prevented with the help of RAG, right? Now, how it will be prevented with the help of RAG, I will talk about it. Okay. So here, instead of fine tuning, I'm saying that, hey, I will go ahead and implement the RAG. Now, you'll understand only when we understand the pipeline of the RAG, which I will discuss in this specific video. Okay. Now, these are the major two disadvantages that you see right over here. And yes, there are some more disadvantages which we'll just deep dive more as we go ahead. Okay. Now, what happens in if we use RAG and how we are preventing it? See, RAG is nothing but it is saying that it's a process of optimizing the output of a large language model so it references an authoritative knowledge base outside of its training data. Now, how do we solve this hallucinating and this problem that we have? Okay. So let me just go ahead and draw the diagram again. Okay. So here is my LLM. Okay. And here is my query. So let's say that I am coming up with a user query. So let's consider it over here. Okay. And here I'm drawing a user. I'm user. Okay. And this user will first of all give a query. Okay. Now what happens is that there will be two important pipelines that will be created. As I said over here, we are trying to optimize the output of a large language model so it references an authoritative knowledge base outside of its training data source. So as you all know, this is my LLM, right? This LLM is already trained with huge amount of data. Now, along with this, I will be having an external database. And this database, we basically say it as vector database. Okay, external vector database. Now you know that this LLM is already trained with some amount of data, and any additional data, let's say my startup data, my policies, HR, finance, whatever data is there, we will try to create a data ingestion pipeline over here. Data ingestion pipeline over here. Now, what will be this data ingestion pipeline? So let's say I have my data. From this data, we will do some kind of parsing. And from this parsing, we will do embeddings. And then we finally store it into the vector store. Okay. Now, whenever we talk about this specific data, this data can be in any format. It can be in PDF format. It can be in HTML format. It can be in Excel format. It can be even in SQL database format, or unstructured format, any format. So what we do, initially we take this data and we do data parsing. Now here, data parsing is a very important step. I think if you crack this step, then developing a RAG application becomes very easy. Data parsing is all about how do you read the unstructured data or the structured data that is present inside this, and how do you chunk this data, right? How do you chunk? How do you divide this specific data into chunks? Chunking is very important because you need to save this data inside some kind of vector store. This is nothing but vector store or vector DB. Okay. Now, vector store and vector DB is nothing but it will actually help you to save vectors inside this. Okay. So once you do the chunking, after doing the chunking, you pass it to the embedding models. Now, here in the embedding models, you basically convert text to vectors. Okay. Vectors is just like a numerical representation for text so that you will be able to apply algorithms like similarity search, cosine similarity techniques that are already available, right? Wherein similar kind of results based on a specific query can be retrieved from this particular databases. Okay. So here, whenever I talk about vector DB, this is my vector DB or vector store. Here we are storing embeddings. Okay. And these embeddings will get applied to every chunks. Embeddings is nothing but we basically we convert text into vectors. Here we can use different embeddings like Google Gemini embedding models. We can use OpenAI embedding models. We can use Hugging Face embedding models. And each and every embedding models exist with different cost, and there are also open source embedding models which will actually help you to convert the text into vectors. Now, this is one specific pipeline which we call it as data ingestion pipeline. At the end of the data ingestion pipeline, you are able to store the text into vectors inside your vector DB. Now, how RAG is different from the previous one, right? So initially you had this data ingestion pipeline where you are converting all your data into vectors, right? And this data is specifically for this particular startup. And now I have created a knowledge base. So this is my knowledge base. External knowledge base or internal knowledge base, whatever knowledge base I have. And this knowledge base does not exist with this LLM, right? Yes, some amount of information may be available, but not the entire part. Now, see the definition. It is a process of optimizing the output of a large language so that it references an authoritative knowledge base outside of this training data. Now, what will happen? When user gives a query, now this query, instead of directly going to the LLM, will go to this vector database, right? And before going, here also we need to go ahead and apply embedding, right? Because this query will be converted into vectors, right? Why we need to convert into vectors? So that when we are hitting this query to the vector DB, this similarity search is basically applied. And based on this, we get some kind of context. We get some information from the vector DB. And now whatever query I'm asking, okay, if I ask, hey, what is the leave policy of my company, right? Now what will happen? First of all, it will go to the vector store. It will gather all the related information that is available over here. And that information, when it is sending it to the LLM, it is called as context. Now we use this context along with, we go ahead and write a specific prompt. Now this prompt is an instruction to the LLM, and it says that you can use this context to answer the question, and finally you get a output. This is the entire pipeline. This pipeline is basically called as retrieval pipeline. Retrieval pipeline. And this is a very good example of a traditional RAG. Now you may be thinking, Krish, what about other types of RAG? Don't worry. Don't worry. I will explain it completely from basic to advanced with implementation, each and everything. Because later on, we'll be discussing about agentic RAGs. We'll be discussing how agentic RAGs actually work, each and everything. But I hope you got an idea with respect to this. Now, here, you will even not be seeing this particular problem. Like, you'll not completely remove hallucination, but some amount of hallucination. If any queries that is asked related to the data that is present in the vector DB, I will definitely get some kind of context, and my LLM will give me the output. Yes. Let's say that if that data is not present over here, then LLM can hallucinate, right? But here we are doing this. See, one best example that you can do is that you can use perplexity. Perplexity is nothing but it is based on RAG. It is completely developed based on RAG applications. Okay, RAG. It is a kind of a RAG application. In Perplexity, you have connected to various retrievers. You are connected to tools. You are connected to web search, right? And then it is summarizing the output and giving by the LLM, right? And it also uses various LLMs itself. I'm also planning to mostly start a startup soon enough, within a couple of weeks, I guess. And the kind of application that I'm developing is a RAG application only. And it solves a very good problem for a developer. Okay. So that is the reason I'm not being able to upload a lot of videos, because I'm pretty much involved in those startups and working and developing a product that India can definitely remember. Okay. And this is how, this is how things are, and you can basically see how good uh, you know the pipeline actually works. And this is basically a traditional RAG. Now you may be thinking, Krish, what all things we'll be discussing? Okay, fine, we have discussed about a traditional RAG. In the future classes, what coding we'll be doing? Okay, so let's go ahead and talk about it. As I said, two important pipelines we'll go ahead and create. One is a data ingestion pipeline and one is a retrieval pipeline. Okay, now in the data ingestion pipeline, you'll be seeing that we will be performing data ingestion. Along with the data ingestion, we will go ahead and do data parsing, then we'll perform embeddings, then we will store everything into the vector store, then we will create a retriever for this, and whenever a user asks any queries, it will be able to give the context to the LLM, and then finally we will be generating the output. So here, this is retrieval, this is augmentation, right? This is augmentation over here. Augmentation basically means what? You're giving a context to the LLM along with the prompt to generate the output, right? So this is basically called as augmentation. And finally, you're generating the output, right? Which is nothing but generation. So here you're basically generating. Now, in the next session, how we are going to implement it. First of all, I will show you how to perform these two steps in a very efficient way. Okay. Sorry, not these two steps. I will show you how we can perform these all steps, right? Data ingestion, data parsing, and embedding. Here we are going to consider different files like PDF, HTML. Okay. PDF, HTML, you can consider Excel, you can consider SQL database, you can consider any kind of files. Then we'll do document parsing and we will try to convert this into document. So document is an amazing data structure which you can basically use it, and you can even parse this, do the chunking and store it in the vector embedding, sorry, vector store. Then we'll perform embeddings. Here we will use both open source and we are going to use paid embeddings for the same. Okay. And then finally we go to the vector store. Then based on a user query, how do we go ahead and apply the same embeddings? We are going to see that. Okay. And then finally we will be developing this. So mostly I really I'm focusing more on making bigger videos so that you don't just follow a playlist. Okay. I want to basically cover a lot of stuff in one video so that you should also be able to efficiently cover it instead of covering 50 different videos, right? Now, when we are doing data ingestion and data parsing, right, there are various techniques. See, we are going to see about optimization. We are going to see about various chunking strategies, context engineering. These all kind of topics will be coming up. When we talk about data parsing, what is semantic chunker, how do we go ahead and do the chunking in those strategies and all. Everything we'll try to discuss as we go ahead. But I hope you got a very super cool idea about what exactly is RAG. Hello, guys. So, we are going to continue the discussion with respect to RAG. Already till now, we have understood what is RAG, then what are the main drawbacks we are fixing with RAG. And along with that, we have also understood how the RAG pipeline is, right? It usually consists of two important pipeline. One is the data ingestion pipeline, and one is the retrieval pipeline, which includes this two box. Okay. Now we are going to go ahead with some kind of practical implementation. Now, the major thing that usually comes in my mind, right, whenever we go ahead and start any new series, that is how should we cover a specific topic, so that we can understand the coding from basics and we move towards modular coding. So that is how I'm going to implement this entire pipeline. Initially, we will go ahead with some basic code. We'll try to understand the fundamentals. And then we will start writing more complex code. We'll be using modular coding also. So initially we will write all the code in Jupyter Notebook. Then we'll increase the complexity. We'll write code in terms of class, reusability. And then we'll try to see that how we can actually create the pipeline. So that is how the agenda will probably go ahead as we go ahead, right? So two important things that we'll think about. The first important thing is to understand about the document structure. Now, whenever we work with any external knowledge database, any data that needs to be fed into the vector DB, you definitely need to know about this document structure. Why? Because inside this data ingestion pipeline, the first step is data ingestion. Now, whenever we talk about data ingestion, here we can have any kind of files, right? We can have PDF files, HTML file, DB file, Excel file. Our main aim is to read all this particular file content and probably convert into a structure wherein we can additionally we can apply strategies like chunking, embedding, and store it into the vector DB. That is what this entire pipeline is all about. So for that, you really need to understand this document structure. So if you see this diagram, right? So since these two are the main topics that we are going to cover in this particular video, initially we will go ahead with document structure, understanding this. And then we'll try to build our complete RAG pipeline. In our complete RAG pipeline, we have two important steps. One is the data ingestion pipeline, and the other one is the query retrieval pipeline. Now, whenever we talk about the data ingestion pipeline, let's talk about this in complete depth, right? So initially you have this data ingestion pipeline. In the data ingestion pipeline, the first step is data ingestion. That basically means, let's say that you may have different kind of files like PDF, HTML, right? Excel, you may have DB file, you may have unstructured file, any kind of file format. So in data ingestion, what is our main strategy is that how to proceed with reading this particular file, how to perform data parsing, and then finally how to convert this into a document structure. So that is the reason in this video, right, as I said, we're going to first of all understand about document structure, how to build this document structure, what is metadata. Now inside this document structure, you will be learning about important components like metadata. You'll be learning about content. You'll be learning about how the structure of the metadata exists, each and everything, right? So we will be covering completely in depth, like how these things actually work, okay? Once you understand this, and this data parsing is really, really important step. Because of this, later in the retrieval pipeline, that is the query retrieval pipeline, based on this parsing, it can become much more efficient, right? You will be able to get the results much more accurate. So that is the reason you need to really focus on the data parsing. Now, after doing the data parsing, the next step usually is something called as chunking, right? So here in the chunking, we convert this entire data into chunks, multiple chunks. So this chunks is like, let's say this is my chunk 1, this is my chunk 2, this is my chunk 3, this is my chunk 4. Okay. Then as we go ahead, after applying chunking, so chunking basically means, and why do we apply chunking? Chunking strategy is very simple. Whatever documents we have, we are just dividing this into smaller parts or smaller chunks. The reason we do this, because whenever we consider with respect to any LLM model or any embedding models, let's say here the next step is all about embeddings. Okay. In embedding, with respect to every LLM model, there is a fixed context size. Okay. Let's say if I take the complete 100 pages PDF and I directly try to give it to an LLM model for performing the embeddings, like if I give it directly to an embedding model for performing the embeddings, and embedding basically means you convert text to vectors. It will not be possible. It will say that, hey, you are providing data more than the context size, and that will not be possible in order to convert the text into vectors. So within the limit of the context size, you really need to give the data. And this is for both embedding models and even in the later stages whenever we use any kind of LLM model, because for every LLM model there is a fixed context size. Yeah, different LLM model may have different context size. So that is the reason, and it is always a good strategy that we try to divide our data into chunks so that we fit them in a way that we in the later stages will be able to efficiently put them into the vector database, which is this. So after chunking, for every chunk, we go ahead and apply embeddings. Okay, so we go ahead and apply embeddings. And from the embeddings, we finally store that into our vector DB. Now inside this vector DB, all this will be stored in the form of vectors. Like let's say this is my record 1, record 2, record 3, record 4, like that, right? So this is 1 record, 2 record, this is my third record, then fourth record, fifth record, right? Like this you have, right? Now from this particular vector DB, you will definitely be able to apply any kind of similarity search. Similarity search. Now, in this specific video, what we are going to do is that I will be using any of this file and I'll create this entire pipeline. Okay, I'll just create this entire pipeline, and you also need to probably work along with me. Later on, for any other files, I will give you an assignment. Okay, I will show you with a couple of files. Let's say I'll take PDF file and I'll show you this entire data ingestion. Then what you do is that as an assignment, you use any of the other file format, let's say Excel, CSV, whatever file format you want, and you try to complete the same pipeline. Okay, so that is what is my strategy. And please make sure to complete the assignment also. And we will go step by step completely from scratch so that everybody will be able to follow. So first of all, I will go ahead and open my empty folder. And in this, remember, I will be using Langchain. And this is just a traditional RAG right now. In the later stages, we will move towards agentic RAG. So from this particular command, I will just go ahead and open my command prompt. I will open my VS Code. So let me quickly go ahead and open the VS Code. Now from the VS Code, the next step will be that I will quickly open my terminal. And let me just go ahead and write UV. I'll just go ahead and initialize this particular workspace as my repository. So YT RAG is my workspace. Now I will just go ahead and also create my environment. So if you're using UV package, so you can just write UV So my Python 3.13.2 will be the recent Python version that I'm specifically using for this particular project. And then I will go ahead and activate this particular environment. Okay, perfect. Till here, we are good enough. Now I will go ahead and create my requirement.txt. Now from this requirement.txt, let me quickly go ahead and install some of the packages like Langchain, Langchain core, Langchain dash community. These all things are there. Let me quickly go ahead and install these packages. So uv add -r requirement.txt. Okay, txt. So this is done, and along with this, I will also go ahead and install some of the libraries like PyPDF, PyMu PDF. Okay, so these are all libraries I'll be using. I'll talk about why I'm using PyPDF, PyMu PDF, right? This is specifically to read my PDF documents. So one example that I'm actually going to show you is with respect to PDF, and then you should also try to create the same pipeline with the help of any other uh, data types, okay, data formats types. Like let's say it can be JSON, it can be anything as such. So my requirement.txt is filled. Now what I will do is that I'll quickly go ahead and create my data folder, and here I will also go ahead and create my notebook folder quickly so that I can start working on it. And then along with this, I will also go ahead and add add ipy kernel, okay, so that I will be able to work along with my Jupyter notebook. So ipy kernel has got executed. Now quickly, I will first of all start with my Jupyter notebook. And at the first thing that I told you, it's related to document data structure, right? Document, what is document? And what is, how document can be very, very helpful if we are using in the document data, in the data ingestion pipeline, okay? So I will quickly select my kernel. And these all things, you really need to be a good at Python programming language. See, there cannot be anything that you can skip Python programming language. So my suggestion would be never do that, okay? So Python is must, and this time I'm just going to use some more advanced coding, and it will not be possible for me to write line by line. So definitely I'll go a little bit fast to in order to explain you. Okay. Now, as I told you, if I go back over here in the data ingestion, our main aim is to load some data, apply some chunking, then convert into embeddings, and finally store it into the vector DB. That is what my entire data ingestion pipeline is all about, right? For understanding this, we need to understand the document structure, because all this chunking that is done, the final output will be documents. Now, what exactly is a document data structure? So here I will go ahead and write what exactly is a document data structure. So for this, I will go ahead and import from Langchain, or to probably show you this, I will be showing you some kind of file so that you'll be able to understand it. Okay, let me put this file over here. Okay, I have some file over here, and then we'll try to understand. Okay, what exactly is a document structure? See, Langchain document structure. So Langchain document is a kind of a data structure which will be able to save some data in some format where we have two important things. One is the page content and one is the metadata. The page content will basically have the content that is present inside that particular file. Okay, so if you are reading the file, inside my page content, all those detail, all those content that is present inside the file will be available over here. And metadata will be some more additional information of the file. Like it can be the file name, it can be how many number of pages are there, what is the timestamp of the file, each and everything. So this way, whenever you read any kind of data and you convert them, right, in a document data structure, this format will be very, very important, because at the end of the day, we will be doing the embedding on this particular data and pushing it into the vector DB. And when we do that specific task, pushing into the vector DB, we will be able to apply different algorithms like similarity search, cosine similarity, and we will be able to retrieve the results. So here you can see that all the information regarding this is given over here. So usually Langchain document structure, it has two important core components. One is page underscore content and one is metadata. And here page content will be the actual text content, where all it will be very, very handy in research papers. If you want to probably create a RAG application on research papers, product manual, so you can specifically use this. In Langchain, you definitely have different loaders. Okay, loaders, like you have something like PDF loader, you have CSV loader, you have web-based loader, you have directory loader. Now see, all these loaders, what it does is that for PDF loader will be used to load the PDF files. And once it loads the PDF file, right, it will be giving you the output of the documents in the form of a document structure. Okay, I will show you practically also why I am specifically saying and stressing on this. Okay, it will definitely give you all the output in the form of a document structure. Similarly, in the case of CSV loader, here we are giving the CSV file, but it will try to convert the entire content that is present inside that CSV into a document data structure. Similarly, with respect to web-based loader, directly loader. Similarly, there are so many different loaders over here. Right? You can use any of this particular loader to load the data, and at the end of the day, this loader will finally give you the output in the form of document structure. Okay. So I hope you got an idea about what exactly is document structure itself. Okay. So now quickly what I will do, I will go ahead and start explaining you about like how we can start with the document structure. So for the document, we need to import from Langchain dot, there's something called as text splitter and Langchain underscore core. It is present inside underscore core dot documents import document. Okay. Now this document, you will be able to see that if you just hover over here, you will be able to see class for storing a piece of text and associated metadata. Okay. Now, if you really want to understand the document structure, so first of all, I will go ahead and create one document. Let's say manually I'll go ahead and create. So I will use this document, and inside this, we will be using two parameters. One is the page content. Let's say this page content I'm writing, this is the main text content I'm using to create RAG. Okay, so I've just basically written some basic content over here. Let's consider that this particular content is coming from a txt file. Okay, but along with this content, if you really want to improve the search query retrieval from the vector DB, you need to also go ahead and write metadata. So the second parameter that you will be able to see is something called as metadata. Now inside this metadata, you can write different information, because at the end of the day, this is text. You can write like, okay, fine, this is my source. The source is basically coming from example.txt file. Okay, then let's say the number of pages are equal to 1. Okay, total number of pages are like 1. I can also go ahead and write some more information like, okay, who is the author for this? Author is nothing but Krish Nayak. So this is the additional details that you will be able to see it. Okay, fine, let's go ahead and write date created. So date created, right? Date created, and here I can go ahead and write 24 minus 01 minus 01, like that's like first 2024 or first 2025. Now why these all metadata will be really important? Because once we consider this document, right, once we do the chunking, once we do the embedding, and once we store into the vector DB, when you're doing the similarity search, you can also apply filters. That is the most important thing of this. And when you apply filters, let's say that I am applying a filter, I'm searching what is the main text content for building the RAG. Some information is there. Let's say there's some information related to the RAG. If I ask that particular question and I say by author Krish Nayak, I just add that particular filter, then it knows from which document to probably pick up, because it is going to apply a filter by using the name of author, right? And that is why this metadata will definitely play a very important role. Now, if I just go ahead and execute this doc, you'll be able to see that, fine, I'm getting this particular document. Here you can see metadata is there, and as you go ahead, you'll also be able to see page underscore content. Right? So these are the two main important parameters with respect to this, which everybody can probably go ahead and use it. Okay. Now I hope you got a very clear idea about it. Now what I'll do, I will just go ahead and create a simple txt file. Okay. Now for creating a simple txt file, what I will do, I will just go ahead and import OS. Okay, and I'm saying os.make directory data/text file. So I'm trying to create this particular, inside this folder, I'm creating this particular folder name. Okay, and if it already exists, I'll say that don't do anything, right? So as soon as I go ahead and execute it, you'll be able to see that, okay, it is going inside the notebook file. I'll remove this and let me go ahead and write /. Let's see. Now you can see over here text file is present. Okay, so text file, I've just done that inside this. Now let me go ahead and manually create a text file with the help of Python code. Okay, so I will just go ahead and use a Python code. See guys, these all are basic Python code. I don't want to write each and every line of code and make it very big. Our main aim should be that understand concepts, quickly show you multiple use cases, and then try to implement this. Okay. So now you will be able to see I have created this simple text. I've given the file name something like this. So let me go ahead and write this to data text files python intro.txt. And this is some content that is present inside that particular key name. Okay. So this is my file name. You can see this is key is my file name. And then here I have specifically my Python content. Okay. Here I'm saying for file content in sampled underscore text.items, I'm telling to open the file name. I'm saying that write the content. Okay, so this file path is nothing but my file name. Okay, so if file is not there, it will try to create python underscore intro.txt. So now if I go ahead and execute this, so it is saying me no directory. Okay, let me just go ahead and create one file. Okay, python intro text file. Okay, I have to give the path because there are two files that is over here. One is, okay, one file is also over here. Okay, so I'll just go ahead and write dot dot. Okay, so now here you can see my sample files has got created, machine underscore learning.txt and python intro.txt. Now what I will do, see, I've created some sample file. I could have also manually created it instead of doing the code. Okay. But I really wanted to show you all these things. Now what I will do, I will show you how to read this particular text using text loader. So one of the loader that is present inside Langchain is something called as text loader. So here I will go ahead and write from Langchain dot document loaders import text loader. Okay. Text loader. So here we have imported text loader, and along with this, see, if you don't want to also use this, see, if I execute this, this is also there. Before, if I talk about it, right, when Langchain keeps on changing its library here and there. So there we used to use Langchain underscore community dot document loaders. This also we used to use import text loader. So any of them you can actually use unless and until you get a deprecated warning. Okay. Now, the question is that how do we go ahead and read the text? So I'll write loader is equal to, I will initialize text loader. Let's give the path. The path is nothing but parent folder. We go to the parent folder data slash text underscore files slash python underscore intro dot txt. So here I have actually given my file name, whatever file name we have actually created. And we can also go ahead and use encoding UTF-8. Okay, encoding UTF-8. So once I do this, okay, and now once I go ahead and read this loader, now what it is giving? It is giving me an object of text loader, right? Now in order to get the content inside this, I will be using loader.load. Okay, and here you will be able to see that I will be getting the document. Okay. Now let's go ahead and print the document. So I will write print document. So let's say this is my document. I'm going to print it. So here you can see in the document, you are getting metadata. You're getting the entire information, and this is your page content. Now this is what it is doing, right? This text loader is by default giving you the data in the document structure as soon as it is reading. And here the best part is that you can also see some of the metadata information has also got updated, like what is the source, right? You can still go ahead and manually change more information inside the metadata. But by default, the best part is that whenever you're using this all libraries, then also it will be able to give you the content in the document structure, which is really, really good. Because in the document structure, you have two important things. One is the metadata and one is the page content. So this is with respect to text loader, right? I've just read the text loader and I'm able to get this in this way. Okay. Now, one more way what I will do, I will show you with the help of directory loader. Like if I have all the important files in my directory, can I read it like that also or not? Okay. So for doing this, let's use one more library, which is called as directory loader. Right. So here you can see Langchain underscore community dot document loader import directory loader. Now inside my directory loader, you can see that I'm giving this particular file. Again, this file should be parent folder does this. And here I've given the pattern to match. See this function, basically you can give a pattern to match all the files. Then you can use loader.class. Loader.class basically means which file you are planning to load. If it is a PDF one, you can directly go ahead and use PDF. Okay, so what I can actually do is that I can also go ahead and insert PDF files over here. I can also provide this in the form of list so that it will be able to read both the content. Okay, so once I go ahead and execute this, you can see here also I'm using the encoding and all these things. And here you can see once I go ahead and write directory underscore loader dot load. Okay, and here you will be able to see documents. Okay, And then now, if you just go ahead and print the documents, you should be able to see this. Okay, I'm getting an error. To log the progress, please install pip install tdk. Okay, so here we have enabled the parameter show progress is equal to true. Let me make it as false so that I don't need to probably go ahead and install this. Now here clearly you can see that there were two text txt file. I got two documents. Yes. Now further you can do chunking and all, right? Based on the number of documents over there, I was able to get it, right? So this is the most amazing part about this. Now what I will quickly do is that let me go ahead and create a PDF file also. Okay, so here I have some examples of the PDF file. Okay, so let me quickly go ahead and copy this and paste it over here. Reveal Explorer, data. I have text files, I have PDF files. Now inside this PDF file, now my main aim is to read both the text and PDF files. Let's see. So here I have attention PDF, this PDF, this PDF. Okay, so this is my one document. Okay, let me go ahead and write the same code, copy and paste it over here. And this will basically be for the PDFs. So for PDF, I will be having from Langchain underscore core dot document loaders import PyPDF. I think PyPDF is not available over here, but let's see where is this specific library. I'm just checking out the documentation. PyPDF. Oh yeah, it should be there. So it should be here inside my community.document loaders. I have two different types of library, PyPDF and PyMuPDF. PyMuPDF is better when compared to PyPDF. It can see PyPDF shows load and parse a PDF file using PyPDF library. And similarly, if you go ahead and see PyMuPDF, it loads and parse PDF file using this, provides method to load this is there. All the information. You can see the differences, which one is better, which one is not better in the later stages. Okay. Now what I'm doing is that I will give the path over here. So from data /data, and here you can see the path is nothing but PDF. Here I will go ahead and write PDF instead of writing text loader. I will go ahead and write PyMuPDF. Let's go ahead and use PyMuPDF. I can also include encoding in this. And here what I will do, I will quickly write PDF underscore documents is equal to directory loader dot load. Okay. And then if I just go ahead and see PDF documents, you should be able to see there are so many different PDFs. Okay, I'm getting an error. Get text got an unexpected argument. Okay, let's remove this. I will not be requiring. I think we don't need to apply any encoding by default. Okay, so here you can see I have got all my documents. Yes. So how many different files were there inside PDF folder? One is attention.pdf, embedding.pdf, object detection. These are some of the research paper. And with respect to this all, we are able to see this. And now the best part is that when you're using PyMoPDF, here the metadata information is completely different. See, creation date, source, file path, total pages, right? Format, see, total pages is 15 for the first one, then 27, then 21. See, you can see it so beautifully. It is there. See, I have also created some of the PDFs there. Also, you'll be able to see some kind of author's name also, right? It tries to bring up all the entire source information, and this is your page content, right? So beautifully you are able to see the entire content quickly, right? So that is what this all PDF is all about. And here at the end of the day, even though we use the specific libraries, we are getting this in the form of a document structure. It is a list of documents. So if I go ahead and say what is type of PDF document of 0, you'll be able to see, okay, it is of a document type, right? Now, that is the most important thing. If you now see that we have understood about document structure, we know how to read PDF and TXT. Now, don't you think you can actually easily find out how to probably go ahead and read the Excel, DB, any kind of files? And this is the task that you really need to do. How you'll do it? Just go to Langchain, document loaders, right? And you will be able to find out everything over here. Just go ahead and try it out. Try it out. Try it out. Try to see if the document structure that you're getting is good or not. So here there are so many different things. You can just go ahead and try it out. If you want from AWS S3, you want from AWS S3 directory, go ahead and just install this particular library, give this. But before that, you have to do the authentication and all, right? Once you do this, And once you're able to do it, you can use any kind of document loaders as you add. But at the end of the day, what is the best thing about this? At the end of the day, you are able to convert everything into a document data structure, right? Now, if you see with respect to data ingestion, here you have actually completed. Now, the next step is that I will move towards chunking. Okay, I'll move and show you how the chunking can be specifically done. What are the different ways of chunking that you can actually do? And then finally we'll see that how we can even convert into embeddings. We'll try to use an open source embeddings for this, and then finally a vector db. So yes, I hope you have understood about the data ingestion part. Now let's move towards the chunking part, where we will understand how we can actually performing chunking, and I have also told you what is the importance of chunking. So guys, till now we have already discussed about the entire document structure, and I've also shown you how with the help of PyPDF loader, Mu PDF loader, and how with the help of text loader, you will be able to read the TXT file and PDF file. All the other files, again, you can go ahead and see the Langchain documentation. You have different document loaders, which I have already discussed, right? And these are some of the document loaders that you can specifically use, which I have already shown you from the documentation page. Now we are going to go ahead one step ahead, because we have just started with this. We understood about data parsing and we were able to create the document structure itself. Now I really want to probably go ahead and do the chunking. Then after the chunking, I also want to probably go ahead and do the embedding. And finally, whatever text to vectors is basically converted, this vectors will be stored in some kind of vector store DB. Okay. So let's go ahead and start building this entire pipeline. Okay. So, and this pipeline will initially build it, will start from complete basics, since this entire RAG series, we are learning from basic stuff, right? So definitely you'll love it. You'll love the explanation that what I'm doing. So here, what I will do, I will go ahead and create one more file quickly. And I'll say, hey, this is nothing but PDF loader dot ipynb. Okay. And here I will go ahead and select my kernel. This is my kernel. And let's go ahead and start the entire RAG pipeline. And this pipeline is nothing but data ingestion to vector DB pipeline. Okay. Vector DB pipeline. We are going to go ahead and build this quickly. So first step, as you know that I already have one data folder over here. So this is what is my data folder. And I definitely have a lot of PDF files inside this PDF folder itself. So first thing first, what I will do, I will go ahead and create a function, saying that wherein I will try to read all the documents from this, and I will try to read the data inside this particular document, that is PDF file. And then we may use PyPDF folder, PyPDF loader, and then finally convert that into a document. Okay, so for this, what I will do, I will quickly go ahead and create a function, and this function will be nothing but this is a markdown. Let me just go ahead and make a code cell. So before I go ahead, I want to import all the important libraries that are available. Some of the libraries that I will be noting down over here is nothing but import OS. Then you have something called Langchain document, Langchain community underscore and Langchain underscore community document loaders. I'm using PyPDF loader and all. Then you also have this Langchain dot text splitter and recursive character text splitter. Okay. So otherwise, instead of writing in a new file, let's go ahead and use, okay, this file is fine. So I will just go ahead and execute this. I don't require the path library. So once I execute this, these all libraries will get executed. Now we will be able to use this. Now, since my first step is related to data ingestion, now whenever I really want to specifically do data ingestion, what I will do is that I will try to read all the PDFs. So we will read all the PDFs inside the directory. Okay, directory. Now, guys, you need to have some knowledge with respect to coding. So otherwise, if I keep on writing line by line, it'll definitely take a lot of time. So here we are going to create a function which is called as process all PDFs. Here we need to give the PDF directory. Once you give the PDF directory, we will probably go ahead and take the path. So for this also, I will be requiring the path library over here. So once we get that path based on the workspace location, Here we are going to get the PDF directory path. Then we'll list of all, we'll go ahead and apply this regular expression to get all the PDF files. Then here I'm printing what is the length of the PDF file. And we are processing every PDF files. So here you can see that I'm using PyPDF loader, str of PDF file name, whatever file name, then I'm doing documents is equal to loader.load. Here I get the document, okay. Here what I'm doing, I'm adding some more information related to metadata. So here you can see doc.metadata of source file. I'm giving the PDF file dot name. I'm also saying that, hey, what is the metadata file type? So this is my new keys inside my metadata to put some more additional information. And finally, you get a PDF. I'm just mentioning some more metadata information. So along with this, I've put up this metadata information like file type, source file. Now you can keep on adding any number of metadata information like you want, right? And once we read this entire documents, we are going to go ahead and store in this particular variable that is called as all underscore documents, which is nothing but it is a list of, it is a list. It is an empty list. Okay. So once we do this, here we'll be able to see it is returning this all documents. So this function, what it does is that from inside a folder, it reads all the PDF files. It reads the content inside this. It adds this kind of metadata information. And finally, it is basically storing in this particular variable. Okay. Now we call this particular function process all PDFs. I'm giving the data folder over here. So once I execute this, you'll be able to see that it has found out 4 PDF files, and attention.pdf had 15 pages, embedding.pdf had 27 pages, and object detection PDF had 21 pages, and this is proposal 1 page. Okay. So all the information I have it over here. Now, if I go ahead and check my all underscore documents. So if I go ahead and check just this particular variable, all PDF documents, you should be able to see that this is my list of documents, right? And the best part is that for every PDF, you'll be able to see by default some of the metadata information. Along with this, you can see there is an author metadata, keywords, mode, date, all this modified date, right? All this information are basically present in the metadata information. Now here, what we have added source. Along with the source, you can see we have also total pages is also added, at source file is also added. And these are my text, which is present inside my page underscore content, right? So for every PDF, whatever is the possibility size of the document, we are able to read it. Now, this is a step that we have done, right? Now we have to go to the next step and perform the chunking. Now, how do I go ahead and perform the chunking? Now I have all my list of documents. So what I will do, I will just go ahead and quickly create a function. And this will be specifically text splitting. Get into chunks. Okay. Chunks I have over here, right? So first of all, I will go ahead and create a function which is called as split documents. And inside this documents, I will be giving my parameters. The first parameter is nothing but documents. Then I have my chunk underscore size is equal to 1000. Then I have chunk underscore overlap is equal to 200. Okay. So I have given all these things. Now you know how to do the chunking. It is very simple. You go ahead and directly use the recursive character text splitter. And for this, we definitely require recursive character text splitter, which we have already imported, I think, right? So on the top, you'll be able to see that we have imported this, which is present in langchain.textsplitter. So inside, we are taking this text splitter, which is nothing but recursive character text splitter. Now this is recursively split all the document size based on the chunk size, that is 1000, chunk overlap 200. Chunk overlap basically means some number of text will be able to get overlapped between two different documents, right? When we are doing the splitting. And here you can see we are also using separators, right? This is just like an empty space, like a blank, this is an empty space. This is one more separator. This is a new line separator. Now you tell me in the comment section, what separator is this? Okay. So we can use different separators. You can also use comma. We'll be seeing different types of chunking strategies in the later stages, but let's start creating this one pipeline. Then you'll be getting a clear idea about it, like how this entire pipeline works. Okay. Then you have this text splitter. Once you specifically have this text splitter, you can actually use this to do the splitting, right? So now what I will do, I will create a variable inside this, and I will write text splitter dot split documents. So we are using the split documents and we are giving the documents, and these all are the default parameters that we are giving over here. Now, once we do the split, you'll also be able to see what is the page content. I'll just try to display the 200 characters from the page content, and you can also see the metadata, right? So once we go ahead and execute this, this is going to return the entire split documents. Now let's go ahead and use this split. Let's say here I'm just going to go ahead and get all my chunks. I will be using this function split documents, and let's give the documents. Here we are going to give the list of documents, right? What are the list of documents? So list of documents is nothing but all PDF documents. So I will give it over here, and let's see the chunks. Okay, so now if I go ahead and just go ahead and print the chunks, you should be able to see that all my data is basically chunked, right? And you can see that we have splitted 64 documents into 359 chunks. So these are all my chunks that we have done it, right? That basically means we have converted all our text into smaller chunks, right? Based on the chunk size and the overlap. So like this kind of chunks, we have how much? 359, I guess. How much it is? 359. Initially, we had only 64 documents, right? For every page, there will be a separate document structure. Perfect. So we have done this, and we have done the splitting part. Now let's go to the next step. The next step will be quite interesting, because now if you see from this particular pipeline, right, what are we doing, right? So here we have done the chunking, but these two are the most important steps. One is the embedding, right? We need to perform some kind of embeddings over here, right? Embedding generation and vector store DB, right? Embedding, you can use any kind of models, but I will try to focus on using open source models so that everybody will be able to just try it out, you know. For this, what I will do, I will just try to use some kind of modular coding. So I will try to create some classes, you know. For embedding, I will create a separate class, and inside this, we will try to define different function. Because in embedding, you know that you are converting text into vectors, right? So for converting text into vectors, I may define different functions like loading the model, generating embeddings, you know, that kind of. And in vector DB, like again, we'll try to create this as a separate class. So let's go ahead and discuss about this, wherein we work on the embedding part. Quickly, let's go ahead and see the embedding part. So for the embedding, I will just go ahead and write a markdown. So let me quickly write embedding and vector store DB, right? So we are going to specifically go ahead and implement these two important modules. Now, first of all, what I do is that I definitely require some kind of libraries over here, right, for embeddings. So for embedding, we are going to use sentence transformer. We are going to use a model that is available in Hugging Face. And for that, I will be using the sentence transformers library. Along with this, I also want to use some kind of vector store. So this is the vector store I may use, that is Fires CPU. You can use Fires, or you can also go ahead and use ChromaDB. So these are some very good open source vector store that is available. Now these all libraries will be more than sufficient to get started with. So quickly, let me go ahead and install it. So I will write uv add -r requirement.txt. So once I do the installation, you'll be able to see that. Okay, the installation will get completed. So once the installation gets completed, it will take some amount of time because we are loading the entire transformers. So here you can see that quickly it has got installed. Now I'll go again back to over here. Now, once I go over here, what is the first step that I'm actually going to do is that I will quickly go ahead and import some of the libraries that I require, like this, right? So I'm importing NumPy from sentence transformer. I'm importing sentence transformer. My embedding model, right, will be available inside this. Then I'm importing ChromaDB. Then we are also importing the settings from this. We are importing UUID. The reason of creating this UUID is that because every record that we specifically insert into the vector DB will have some kind of ID over there. We'll generate that. Then along with this, we will also be importing list, dictionary, any, and tuple. And since we are going to apply cosine similarity while doing the retrieval from the vector DB, I also will be importing this, and this is available in scikit-learn. So let's quickly execute this. Okay. And till then, I will go ahead and create more number of cells. Now, as I said, for embedding, I will go ahead and write one different class. So I will say embedding manager. So this will be responsible in doing the embedding part. So first thing is that once I am creating this, for every class that we specifically create, we need to write an init function. Okay. So init. So this is my constructor. You'll be seeing that it handles document embedding generation using transformer. Here we are initializing the embedding manager, and the model name that we are giving is all mini LM L6V2. So this is available in Hugging Face, this specific model, all mini L6V2, and this is responsible in specifically converting a text into vectors, and you get somewhere around 384 dimensions. Okay. Then we initialize the embedding manager. Then model name is nothing but Hugging Face model name for sentence embeddings. We are going to use this. Okay. So here we are initializing the model name. We are saying self.model is equal to none. Okay. Because here later on we'll initialize this value. This function is very important, load underscore model. So that basically means my next function will be load underscore model, and this model work is very simple. This function work is very simple. It is going to load this model, that is all mini L6V2. Okay. So I will create another function which is nothing but underscore load underscore model. Why we write underscore? This is just like a protected function. If you know about classes, we use something called as a protected function, and within this protected function, within this class only, it will be accessible. So here what we are doing, we are using the sentence transformer, and whatever model name we have, we are loading it. Okay, we are loading it. So self.model of sentence transformer model, self.model name, then this will be modeled loaded, and here you'll also be able to get the dimension. For that we use a function called as get sentence embedding dimension, and by default it will be somewhere around 384 dimensions. Okay. That basically means every text will be converted into 384 dimensions. So once we have this init function, we have the load model. Now one more function that we require is generate embeddings, right? So here you'll be able to see that I will be seeing this generate embeddings function. Okay. So generate embedding is nothing but it takes the text, that is nothing but list of string, and it returns a numpy array. Okay. So here it generates an embedding for list of text. Very simple. So here what we are doing, we are basically using this self.model. Dot encode is the function that we have to use on text, whatever text list of text we give. And we are also giving show progress bar is equal to true, so that we should be able to see that progress bar, and we return the embeddings. Okay. Now generate embedding is one function, load model is one function. We have also used get sentence embedding dimension just to get the dimension. Okay. Now for this, you can either you can either create this particular function, or you can also remove this. It is not necessary. But what I did is that to show you much more in a better way, we will create this function get sentence embedding dimension. So here is my get embedding dimension self. So here what we are doing, we are just written model.get sentence embedding dimension. See, instead of doing like this also, I can write like this only over here. Okay, I can just quickly write this particular function over here. Okay, so sometimes it is not required. You can also, so I will just go ahead and remove it if you want. Okay, I will just remove it. Perfect. So I have these three important functions. Now we can initialize the embeddings. Okay, sorry, we can initialize the embedding manager. So here I will write embedding underscore manager is equal to embedding underscore manager. So I hope this is the class name. It should not be underscore, it should be like this. Okay. Now once I go ahead and write this, and once I execute it, this will just go ahead and initialize the constructor, right? So here you can see it is loading the embedding model all mini LM v62 model loaded successfully, and here you can see the dimension is 384, right? So it has been loaded. So when we are calling this particular function, this is basically getting loaded, right? So my embedding manager now has the model information over here. Great. So I have my model ready. So if you see from this particular graph, this entire class has been created. Now we go to the next step and create this specific class. That basically means over here, we have our model embedding ready. We just need to use it. Now, similarly, we will go ahead and create it for the vector store also. Okay, vector store is just like a vector DB database where you can store all the vectors that is being converted by the embedding layer inside it, so that you can apply any kind of similarity search into it, right? So first of all, let me quickly go ahead and define a class for this also. So here I will go ahead and write vector store. Okay, vector store. Remember guys, the code that I'm showing you, it is very simple. If you just see, you need to have some coding knowledge if you really want to become better in RAG. Okay. Now we'll go to the next step with respect to the vector store. Now in the vector store, we are creating a class vector store. Again, here we are using an init method. We are giving a collection name. What should be the collection name for the vector store itself? And here, the collection name, we are giving it as PDF documents. We are also giving the persistent directory, which will be this particular directory that is inside my data folder. Persistent directory means whatever vector store is basically created, we are going to save it that in the hard disk. So here, first of all, I'm giving the collection name, I'm giving the persistent directory, collection is none, self.collection is equal to none. Okay. And then we are initializing the store. Now, whenever we initialize the store, that basically means this function will be initializing the vector store itself, right? So for this, we need to create another function again and see the code. Okay, just observe the code. Here we are initializing ChromaDB client and collection. So here we have written os.make directory of self.persistent directory, whatever directory path is there. If it already exists, we are just going to keep it like that. Otherwise, it is going to create a new directory. Then we create a client, self.client, wherein we are using ChromaDB.persistent client function, and we are given the persistent directory over here. So what it is going to do, it is basically going to create a client which will be having a reference to the ChromaDB vector store. Okay. Then we go ahead and create a collection. So here we write self.collection, then self.client.get or create collections. We're giving the collection name and we're giving some metadata information, like what is the collection information. And here we basically create a collection. Collection basically means it's just like where we are going to store the where we are going to store the vectors inside my vector store. So it will be stored inside this particular collection name. Then we are initializing this with the collection name dot collection count. Okay. So as soon as we execute this, that basically means my ChromaDB client will be ready and my collection will be created. Okay. Now, the next function is that usually whenever we create a collection, we need to add the documents, right? So for documents, we will be creating another function. So quickly, let's go ahead and create this, because whenever I have a document, I will go ahead and create this particular connection. Okay. So here you can see I've created another function which is called as add document. Here we give the list of document, we apply the embeddings. Very simple, add documents and the embeddings to the vector store. And here you can see if length of documents is not equal to length of embeddings, here you can actually see this. Now we are preparing the data for ChromaDB. We require IDs, metadata, document text, and embedding list. So now whatever documents I have over here, whatever documents I'm getting, I will be zipping it, means I'm creating a tuple with embeddings. And then I am creating a UUID. Why I require UUID? Because it's just like a ID for a specific record, right? And that will be my doc ID. Okay, doc ID variable, and I'm appending it over there. Then we are preparing the metadata, whatever doc.metadata we get. Remember, we are iterating through these documents, so we have all the information. So that all metadata we are putting it over here, doc underscore index, content underscore length. We are just adding some more metadata information to put it inside my vector DB. Then we get the document content from doc.page underscore content, and we also get the embedding where we are converting this embedding to list. Okay. See, two information is basically required right over here. If you see from this particular function, one is embedding, which is my mp.nd array, right? And this embedding is coming from where? From the previous function, right? Generate embeddings, where we have done it. So it's all linkage. See, the reason of creating this particular in the form of class, because I want to link each and every pipeline, right? So here we are writing embedding list.append, embedding.toList. So we have the page content, we have this list. So what I'm doing, I'm adding that entirely in the collection. So for this, we require IDs, we require embedding list, we require metadata, we require document text. So whatever we have prepared, we're just adding it over here based on the parameters, right? And finally, you'll be able to see the how many number of documents has been inserted. Now quickly, let's go ahead and initialize. Let's go ahead and initialize my vector store. So I'll write vector store is equal to vector store, and I'll initialize this. Okay. So quickly, I will go ahead and write vector store. So now this is basically going to initialize the entire vector store itself, right? So here you can see this is my collection name, and existing document in collection is 0, since we did not add any number of records. Okay. Now, if we want to add any number of records, we have to call this function, add documents, right? So let's go ahead and do that, and let's call it. Okay. Now, first of all, you know that I've already done the splitting of the chunks, right? So here, if you go ahead and see this, this is my split underscore chunks, right? Sorry, that was the variable. Let's see which variable it has got saved. Okay, it should be chunks, right? So these are my chunks, right? Now chunks, what I am actually going to do is that I will extract all the text from that particular chunk and we'll generate an embedding. Okay. So for that, what I will do, I will say, I will put a list comprehension. So here now let's convert the text to embeddings. Okay. We're going to go ahead and do this. And here we are basically going to write chunks. First of all, I'll iterate. Okay. I will say that, hey, for doc in chunks. Okay. And we are just going to take this doc dot page underscore content. Okay. So we are going to take all this page content and basically go ahead and create my text variable. Okay. So once I go ahead and do this, you should be able to see this is my text, right? All the text that I have, and this text I will pass it to my embedding manager, right? Embedding manager, which I have actually created. So what I will do quickly, I will just go ahead and execute this once again. I have all my text. Okay. I have all my text. Now from this, we will go ahead and generate the embeddings. Now, once we generate the embedding, how do we generate the embeddings? Very simple. We use this embedding underscore manager, which object we have actually created. What object we have created earlier? If you see over here, this is my embedding manager, right? So we are using this embedding manager dot generate embedding. And here I have to give the text in the form of a list of strings, right? So here quickly, I will call this particular function dot generate underscore embeddings. Okay. And here you will be able to see that I will be giving my text. Then let's store in the vector database. So after we convert that into an embedding, we store everything in the vector database, right? So here I will use vector store vector underscore store, the variable that we have created, dot add underscore documents. And this is a small letter, add underscore documents. This is a function that we have used, and inside this, if you remember, we have to give our entire chunks, okay, comma, whatever embeddings we are specifically applying. Okay. So once we do this, you can see this embeddings, whatever we have got, and the chunks, the documents, the entire documents, we are going to do this. Okay. So let's quickly execute this. And I think now my embedding will happen. Now you can see that for 359 text, this is happening and it has got converted into so many number of batches. Vector store is not defined. Why it is not defined? Let's see what I have defined over there. Okay, it should be vector store. So this should be the spelling of my vector store instead of that. Okay, so now let me quickly go ahead and execute this. Now inside that same vector store, it'll get executed. Okay, perfect. Now you can see that the total document in the collection is 359. So if you see over here, inside my notebook file, inside my data file, here there is something called as vector store, and we have done the persistent over here, right? So persistent basically means it is saved in this particular hard disk. We can just load this hard disk and we can probably go ahead and execute anything as such. Okay. Now, perfect. Now you can see that we have completed this entire pipeline. Now we have all the data available over here in the vector store DB, right? In the form of vectors. But now the main thing is that how do we perform the retrieval? Because the retrieval, see, in retrieval, what happens is that whenever we have a user query, we have to take this query, we have to convert that into embeddings again. Okay. And then we basically go ahead and hit the vector store in the form of a retriever. And then only we get the context. So in our example, first of all, we'll try to get till here. Okay, we have a user query, we convert that query into embeddings, then we hit this particular vector store and we get the context. So let's go ahead and create this specific pipeline now. Okay, and for this pipeline we will try to create a RAG retriever. Okay, so we will try to create a RAG retriever. So let's quickly go ahead and do that particular thing. Till now we have created all the amazing pipelines. We have created this embedding manager, now we also have this vector store. Now what I will do is that I'll create another pipeline which will be a RAG retriever. Okay, just to get the specific context. So let's go ahead and discuss about that. So guys, now let's go ahead and create the RAG retriever pipeline. So first of all, what we are going to do is that I will go ahead and create a class which is called as RAG retriever. Now this RAG retriever class, you will be able to see that it handles query-based retrieval from the vector store. So inside the constructor, we will be giving two important parameters. One is the vector store and one is the embedding manager. And if you remember, we have created both this. We have created the embedding manager, we have created the vector store manager, right? Now, after giving this, we will be initializing two class variables, that is vector store and embedding manager, and we'll be assigning with this. Now, whenever we create a retriever, one thing you really need to understand, this retriever is actually built on the top of a vector store. And retriever is nothing but it is a simple interface based on whatever query we get. This retriever is just going to give you the response back. Okay. And this retriever is basically a kind of interface which is connected to the vector store in short. Okay. Now, the next step that we are going to create is another function which will be called as retrieve function. Now, this is really important because this retrieve function main work is to retrieve based on a specific query. So let me go ahead and define the specific function. Now this function, again, see, to write it will definitely take a lot of time. So we will try to understand this particular function. Okay. So here a retrieve function, you can see we are giving query, we are giving top k results, how many top k results we want. And there is also a threshold value. By default, it is 0.0. And this function is basically going to return a list of results. Okay. So here you can see retrieve relevant document for a query. Arguments are the search query, top k documents and score threshold, and it returns a list of dictionaries containing the retriever documents and metadata. At the end of the day, this function is actually help us to get this specific context. So you will be able to see over here, we are using that same self embedding manager and we are calling this generate embedding function. Now, if you remember, this generate embedding function is already defined in my embedding manager, right? So if I go on the top, so here is my generate embedding function. And this is nothing but this is basically, you're just using model.encode and you're giving the text and it is converting into embeddings. Yeah. So that is the reason we are basically using this. Because at the end of the day, first of all, whenever we get a query, right? So let me go down over here. Inside this retrieve, whenever we give this query, first the query needs to be converted into an embeddings, right? So this query that is given, we need to apply embedding for this also so that we can do a similarity search in the retriever itself, right? So the first, the query is basically converted into a vector by the help of embedding manager generate embedding functions. Then we are going to use the vector store dot collection and we are going to use this dot query. And here we are going to give our query embedding, which is nothing but this embedding in the form of a list. And then we are also going to give the top k results. So by using this, this is basically going to hit the vector DB, whichever vector DB we have initialized, and it is going to give you the results. Once you get the results internally, there will be a key which is called as documents. Okay. You can get the document information, the metadata information, the distance information, and some of the IDs information. So all the specific information we are using it. And here you can see very similarly what we are doing. We are using all these parameters like ID, documents, metadata, and distance. We are zipping it. Zipping it basically means we are just trying to create a tuple over here. And then for every values, we are just trying to calculate the distance, right? 1 minus distance. 1 minus distance will basically give you the similarity score, like how similar those text data is basically coming up outside this vector store. So we are getting the similarity score. And if the similarity score is greater than the threshold, then what we do, we basically add this inside my text context documents.
And context documents is basically created in this particular variable, which is nothing but retrieve docs, which we have kept it empty over here. Okay. So all the information we are just trying to add it over here so that we will be able to see it. Okay. And finally, we return that retrieve docs. So if you say step by step, we're not doing anything. We like not very complex thing. We are getting the user query. We're converting this into embeddings. We are hitting the vector store, right? Then we are getting the response. Okay. Once we get the specific response, that context, we are putting it in the form of a list. If you just go ahead and see the code, that is how things are happening. Okay. So this is one of the very important function that you will be able to see. Now here, what I can do is that I can quickly go ahead and create a variable called as RAG retriever, and I can call this same class. So if you see over here, I will use this same RAG retriever over here, and let's give our vector store, vector underscore store, which I have defined it earlier, which is my vector store manager, and then my embedding manager. Once I do this, I should be able to see this. Okay, it should be vector store file, right? So now you will be able to see this is my RAG retriever. RAG retriever, it is an object of this. Now, if I call this particular function with a query, right? I can call dot retrieve with a query. So let's go ahead and do this. Okay, so here I will write RAG underscore retriever dot query. Sorry, dot retrieve is my function. Okay, so here you can see quickly, this is my function retrieve, right? And I need to give a query. Now let's test for a specific query. I'll say, hey, what is attention is all you need? Because I know inside my data there is a PDF file which is called as attention, or I have also created some kind of proposal over here, embedding, some files are there. So we'll try to execute this. So here you can see, as soon as I asked what is attention is all you need, now it is giving me the top K for all, it is printing all the information, and it is generated embedding for one text, right? And the text shape is 1,384 because I've used the embedding that is called as all mini LMV6 that creates a 384 dimension. Now, once we go ahead and apply this particular function, right? This function, it is basically getting the results over here, and we are printing that same thing, right? And at the end of the day, we can also go ahead and return this retrieve docs. Okay. So in short, this is basic. This function is going to give me all the retrieve docs. So this is the retrieve docs. You can see content, metadata, author. So these are my context information. So here you can see attention function can be described as a mapping a query as a set of this one. And this entire thing is basically the context. So from this particular diagram, here you can see easily we are able to get the context, right? And this is nothing but this is your context. Now let's try some more things. Okay. I will just go ahead and open some PDF. Okay. This is some very new research paper, COSO embedding technical report. Okay. We'll search for any topic over here. Embedding model training. I'll just go ahead and search for unified multitask learning framework. Okay. Because this information also we have put it over there. So here I'll go ahead and create one more, this one, and I will copy this entire code. Okay. Quickly. And this is the query that I'm actually going to give. That is nothing but unified multitask learning framework. So if I go ahead and execute this, you can see that I'm able to get this. And then you can see content, benchmark, ranking over on both the leaders, effectiveness of our approach. So we are able to get the response very, very much quickly. Right? And this response is basically coming from the vector store. Right? In a very similar way, very easy way, we are able to get the specific response over here, right? And let me tell you, right, this is the most easiest way, like how things are basically happening over here, right? Now, what we can do is that, see, if you have created all these things, right, till here you have created. Now, the further step is that you have to just integrate LLM with this specific context, okay? Now, for this LLM with this specific context, what you can do is that you can directly take this particular context and give it to the LLM. And that is what we are going to see in the next video. But in this particular video, we saw the entire thing, the complete RAG pipeline from data ingestion to the vector DB pipeline, right? Now you can go ahead and write any kind of queries, and definitely with all this information, and here you can see similarity score is also coming up, right? Distance is also basically coming up. All the information you're putting it over here. And we have also used modular coding, right? Now in the next step, what I'll do, I will take this vector store and we will go ahead with the next integration, that is LLM and output, which I will say it as a retrieval pipeline. But this entire data ingestion pipeline with this query retrieval we have actually created. Now the next two steps is this one. And after doing this, we will try to convert the same code, whatever code we have basically written over here, in the form of modular coding, right? We'll try to see that how we can put this inside our source folder. So here what I will do, I will quickly create a source folder, and inside this source folder, I will show you that how we can take this entire pipeline and how we can actually create it in such a way that we have a kind of pipeline over here, right? Pipeline basically means from data ingestion to vector embedding, how in a sequential way we can actually go ahead and call it. Hello guys. So we are going to continue the discussion with respect to RAG. Till now, we have already discussed about the entire data ingestion pipeline. And with the help of user query, we are also able to retrieve the context. We have completely implemented this first pipeline that is called as data ingestion pipeline, where we did the data ingestion, we did the chunking, then we converted the text into vectors, and after that, we were able to probably store everything inside a vector DB. And we also persisted in the local directory so that we can always read whenever we definitely want, okay, based on a specific query. Now we are going to go towards the second pipeline, that is the query retrieval pipeline, wherein we are also going to use LLM with it. Okay, so here we are going to specifically use LLM models. And these LLM models will actually help us to generate a summarized output, okay, in the RAG. So the entire pipeline will look something like this. And when we talk about this query retrieval pipeline, we are specifically talking about something called as augmented generation. Okay. See, in retrieval, RAG basically means retrieval augmented generation. And this augmented generation, how does it specifically work? Okay. So let's consider that this vector DB is already ready. And you know that how did I create this particular vector DB? By following this particular pipeline, right? Now, once we follow this pipeline, the data is stored inside the vector DB. Now, whenever a user gives a new query, okay, it has a new query related to the documents that are already ingested inside the vector DB. Then what we do, we take up this query, we apply the same embedding. And in this particular embedding, what we do, we convert the query to vectors, right? And then from this particular embedding, we hit the vector DB, we get the context, and then whatever context we get along with the prompt engineering, like basically with a simple prompt, we give that instruction to the LLM, right? So prompt is just like an instruction to the LLM, like how the LLM should basically work. Now, once we are doing this, right, this step is basically called as augmentation. Okay, this step is basically called as augmentation, wherein we are taking the context, and along with that we are also combining it with a specific prompt. And finally you will be able to see that we'll generate the output from the LLM, and this step is nothing but generation, right? This is the retrieval step. So here I have my retrieval step, wherein we are giving a query, we are converting that into vectors, and we are hitting the vector DB. So you really need to understand the entire concepts with respect to RAG. Okay. So let's go ahead and implement this entire retrieval query retrieval pipeline along with the LLMs. Okay. Now here we are also going to go ahead and set up the LLM. So guys, now let's go ahead and implement this with the help of practical implementation. So here we are going to integrate vector DB context pipeline with LLM output. As suggested, we are going to implement the augmented and generation. Now, first of all, what we are going to do is that I'm going to use my Grok API key. Okay, so I've updated the Grok API key over here in the .env file. And, here we are going to probably go ahead and create a simple RAG pipeline, okay, with the Grok LLM, okay. So first of all, what we are going to do is that, again, if you remember in our requirement.txt, we will go ahead and import these two libraries that is called as Langchain dash grok, and then you have python.env. Okay. And then after this, we will go ahead and quickly initialize from Langchain underscore grok import chat grok. Okay. Along with this, I'm also going to go ahead and import OS. Then from .env, I'm going to use load underscore .env so that we import or we load the entire environment variables. Then the next thing is that we will go ahead and initialize the grok LLM and set your environment a grok API key inside this. Okay. And in order to do this, again, here you'll be able to see that I'm using grok API key os.getEnv, something like this. Okay. If you just go ahead and call this. Sometime my suggestion would be that directly don't call from getEnv. Initially, you can directly test it by pasting the environment keys directly over here. Okay. So here I will go ahead and paste it. Otherwise, you go ahead and replace it. Just for testing purpose, I'm actually doing this. Now we'll go ahead and initialize our LLM model, chat grok. And here I will use my grok API key is equal to grok API key. Okay. And then model name is Gemma2. Temperature, I will select it as 0.1. A maximum number of tokens it will generate is 1024. Okay. So this is my LLM. We have initialized the grok LLM. Now the second thing is that we will quickly go ahead and create a simple RAG function. And this is going to integrate everything from retrieve, context plus generate response. And if you remember, guys, here is my retriever. Before class, like the previous session, we have already seen that how this RAG retriever was actually created. We created a class for that. Okay. So here we are going to probably take two different parameters inside this. We'll first of all define a function called as RAG underscore simple. And then here we are going to go ahead and give our query. Then we are going to go ahead and give our retriever LLM top underscore k is equal to 3. Okay. And then over here, quickly, let's go ahead and first of all retrieve the context. Yeah. So we're going to retrieve the context. So here I'm going to write results is equal to retriever dot retrieve query. So here you have this query and top underscore k is equal to k. Okay. And then we are just going to get the context, or I'll go ahead and define my context. Inside this context, I will say that, hey, whatever information I'm getting from my results, right? Just go ahead and combine everything and put it inside this, right? So here I'm saying that, hey, for doc in results, whatever content I'm getting, I'm going to join it with a double new line over here. If results are this empty, we are just going to keep it as empty. So this is my context over here, right? Then I can still go ahead and write one more condition saying that, hey, if not context, okay, we are just going to go ahead and return saying that no relevant context found, okay, to the answer question. And then we are going to generate the answer using grok LLM. Okay. And now I'm just going to go ahead and define my prompt. Obviously, I require a prompt. If you remember here, I can again use a prompt template also. I can directly use a prompt over here. So here with respect to the prompt, I will give a query saying that, hey, this is what you really need to do. You need to go ahead and answer this specific question and you should probably get a response for that, right? So here, what I will do, I will quickly go ahead and paste it. Use the following context. So here you can see use the following context to answer the question concisely. Okay. And here, what we can basically do is that we can just go ahead and do one thing on over here quickly. I'll say just put tab. Okay. So use the following context to answer the question precisely or concisely. So here I've given the context, here I've given the query. Okay. Now the next thing after this is that we will go ahead and create a response. So response is equal to, this time we are going to use LLM dot invoke. Okay. And here, let's go ahead and put something like prompt dot format. And here we are going to write context is equal to context. And here you have query is equal to query, whatever query I have. Okay. And then we go ahead and return the response dot content. So once we do this, then we can specifically call this particular function. Okay. So now what we are going to do is that I will just go ahead and write answer is equal to rag underscore simple. And let's say I go ahead and ask a question. What is attention mechanism? Okay. And here I need to give my rag retriever along with the LLM. And then we can go ahead and print the answer. Okay. So here you can see attention mechanism is a function that maps a query in this, right? And we are able to get the answer over here. This is really good. See, a very simple pipeline where I have initialized my LLM model. I've defined a function. And then this function, what it is doing, first of all, it is hitting the RAG retrieve function. It is getting the context. It is combining the context. And along with the prompt, we are hitting the LLM. So if you remember, we are just following this entire process and generating a proper output, right? If that particular output is available inside the vector DB, right? Now, guys, what we are going to do is that we are going to enhance the RAG pipeline, the simple RAG pipeline that we have created over here. Okay, we'll enhance in such a way that it will have more amazing features in it. Okay, so now we are going to go ahead and create an amazing enhanced RAG pipeline, and this is the code. So now you can see over here we have a function called as RAG advanced. I'm giving a query, retriever, LLM, top key elements like how many we want, minimum scores, return context is equal to false. So here you can see that before we were simply like we were just combining the context, we were putting the information in the prompt, and we were probably generating the response. In this, what we will do is that here we are going to generate this entire RAG pipeline with some more additional features. Like what all additional features we will be requiring? See, here we are directly getting the answers, right? But we do not have much information about the source, about the context over here, right? So here what we are doing, we will return answers, sources, confidence score, optionally full context. Okay. So first of all, again, the code will be similar where we are retrieving the context. So this becomes my context when we are retrieving it from retriever.retrieve. And then I've written if not results, if results are empty, we are saying that no relevant context found. And here we are giving sources is blank, confidence is 0.0, and context is blank. This context is basically coming from the vector DB. Let's say that if we are getting some kind of results over here, we are combining all those results and we are preparing the context over here. And then we are adding sources. See, this sources, which is the list, here we are adding metadata information, source file, right? And along with that, you can see metadata page number, from which page number you are able to get. Then what is the similarity score? And here what I will do is that I will just try to go ahead and display at least 300 length of the content, right? So up to 300 characters we'll try to display. And then we are going through each and every docs that is available inside this results. Then we are going to calculate the confidence. We are actually getting that information in this doc similarity score. Here is my prompt. In this prompt, we are giving context, query, each and everything, and we are invoking it. And the output will be in this format. So let's now go ahead and execute this RAG advanced function. Here I've given all the information, like I've asked what is the attention mechanism, what is RAG underscore retriever, like RAG underscore retriever I'm given over here, LLM, return context is equal to true, minimum score, all these things is given, right? So now I'll go ahead and execute this. Now, as soon as I ask what is attention mechanism, here you will be able to see that I'm getting this particular information, right? And it is also giving me the source information, which number, page number, what is the score, and what is the preview information. Along with that, here is my final information that you can see, right? Where we are displaying the first 300 characters. Let's say that I go ahead and change my question. Okay, I ask something else. I'll say, hey, attention mechanism was one of the thing, but if I go ahead and see my data, my PDFs, okay, I will go ahead and ask something else. Okay, let's see what I can ask. So I'll go to embeddings.pdf. I'll say okay, and then let me search something else, right? I will say hard negative. I'll ask this question, hard negative mining techniques. Okay, so I will go to my question over here, hard negative mining techniques. Okay, and I'll go ahead and search this thing from my vector retriever.
So here you can see that I'm able to get this entire information. The test describes several hard ANCE, Conan embeddings, NV retriever, all this information. And again, you can see that embedding.pdf page 4, I'm able to see all the information along with the context, right? So this is really amazing. And here we have just created an enhanced RAG pipeline. Why we say this as an enhanced RAG pipeline? Because here we are providing information related to answers. We are providing information related to confidence score and each and everything. Now, let me just show you one more amazing way. And this is also an advanced RAG pipeline, but this time I will tell you to probably go through this particular code and tell me. So here what we are doing, we're doing streaming, citation, history, and summarization. So all these things we have included over here. And you can just go and search for this and you can see the answer. Okay, final answer, role element context found, because that question may not be there. Okay, I will just, or let me just change this minimum score to 0.1. I think we should be able to get something. Still nothing. Let me change the question. Let's say hard negative mining techniques. And here we are just going to go ahead and display this particular output. Okay. So now you just go ahead and explore this. Okay. I'll keep this for you. At least see some kind of coding. Okay. So here we are not able to get anything as such. Let's see advanced RAG query, hard query, top querying, summarize is equal to true. No relevant this one. Let's see that I go ahead and ask what is attention is all you need. Okay, I'll go ahead and execute it. So here you can see that I'm able to see all these particular answers over here, right? Yeah, for some of the queries, this will not, it is not giving. There may be some problem with respect to the context size, but it's okay. You can try out with different things. If something is not coming, then we'll try to optimize that also. As we go ahead, we'll try to see this. So here we have seen 3 amazing RAG pipelines. One was a simple RAG pipeline. Here was an enhanced RAG pipeline. And here in the last one, we have made sure to put streaming, citation, and history and summarization with all this kind of information over here. You just go ahead and check it out, all the information, and just see the code. I think you should be able to understand it. So overall, if you see, I hope you were able to understand this particular video. And yeah, this was about RAG pipeline. Now in the upcoming videos, what we will do is that we will try to create some modular coding, because see here, the entire everything is basically created in one IPYNB file. So guys, now it's time that we implement the entire RAG pipeline in the form of a modular structure. Already in our notebook, we have seen about pdfloader.ipynb, wherein we discussed how to probably go ahead and create the entire data ingestion and how to probably store all the information into the vector DB. And finally, you're also able to make the query, right? Along with that, I have also shown you how to work with TypeSense, which was an open source vector store itself, which was also again amazing for searching anything in a quicker way, right? Now, all the kind of implementation that we have done, what we are going to do is that I'll try to show you how in a modular way you can go ahead and integrate this in a form of a pipeline. Okay. So already we have this source folder. Now inside this source folder, what I am actually going to do is that I'll go ahead and create my _init_dot.py file. And after creating this particular file, what is the next step is that I will go ahead and create all my components, important components that will be required in order to create your RAG pipeline. The first important component is nothing but data underscore loader, right? Data underscore loader dot py file, right? So this will be my first component, because initially we need to load the document, we need to do the chunking, and then we need to probably go ahead and store it into the vector store, right? So inside my data loader, I will just try to go ahead and read all the documents that is actually required. Okay. Then after this, the next step should be your vector store, right? Now the vector store, what vector store we are basically going to use. So for that, I will be creating my another file. So here inside my source, I will go ahead and create one more file, which is called as vector store.py. Okay. So this is my next file that is basically created. Okay. Along with this, while actually inserting anything into the vector store, I also need to probably go ahead and do some kind of embeddings, right? And I will try to show you some open source embeddings that we are going to use. So for that, I'll be creating my embedding.py file. And finally, the last file that I really want to create is something called a search.py. Now my entire RAG pipeline needs to be integrated in such a way that there should be a linkage between all the specific files. Now the first case is that I will go ahead and start working on data loader. Now, data loader work is nothing but it should be reading this particular data. Okay, it can be from any source itself. We will try to read this specific data itself, right? So for this, what I am actually going to do is that I will go ahead and import some of the libraries. So quickly, I will go ahead and import these all libraries like PyPDF loader, text loader, and all. Okay, so I'll start working on this because I need to form a pipeline itself, right? So inside this particular file, my main code should be in such a way that I will go ahead and read all the documents, let it be of a PDF, text loader, or CSV. Okay, here I'm also going to give you some of the assignments because in this entire series of videos, we have discussed about this. Okay. So quickly, what I'm actually going to do is that I will go ahead and create one function, which is basically called as load all documents. Now see this, okay? So here I'm just going to go ahead and write this function. Now please have a look onto this particular function. This function definition is load underscore all underscore documents. I'm given the data directory. This should be in the form of string format, and it is returning list, right? List of anything, right? Of any kind of data type. Now, the main important thing about this function is that it loads all supported files from the data dictionary and convert to Langchain document data structure. Because as soon as we read any kind of data like PDF, CSV, TXT, right? We need to probably go ahead and convert that into a Langchain document structure. Then only we'll be able to apply the chunking. Okay. So here you can actually see that I have used data path of the data directory itself. The data directory I will be giving in the runtime. And obviously by just seeing this, the data directory is nothing but data itself. Okay. Now this is the code specifically to read all the PDF files. Okay. So here I have created a list documents, which will be storing all the documents itself. Here we have used datapath.globe function. And here I have used this pattern, this kind of regular expression to match all the PDF files. So what it will do is that inside this data directory, it will start looking for all the PDF files. So inside this, you know that inside my PDF folder, there are some PDF files. So it is going to go ahead and read all these particular PDF files. Okay. So once it reads the PDF files, we will be having those PDF files over here in the form of a list. Okay. Then what we are doing, we are writing for PDF in PDF files. We are going through every PDF, and then we are using PyPDF loader to read the content inside this, and we are using loader.load. And finally, I get all the information over here, and we are going to extend that documents. Now, this is just an example of PDF files, right? Now, same thing you can also do over here for text files. Okay, text files. You can also do it for CSV files, right? See, similar kind of code is basically suggested by GitHub Copilot, but I really want to give you an assignment. Okay, so this will be for CSV file. This can be for SQL files, any kind of files that you really want to work with. You can go ahead and write that particular code and keep on appending inside this particular documents. Okay. So as soon as you do that, automatically you'll be able to do this specific stuff and you'll be able to get all the documents. Okay. Now what I will do, just to test it out whether my PDF files is working fine or not, I will just go ahead and create one app.py file over here. Okay. Now inside this app.py file, let me go ahead and import some of the libraries. So first of all, I need to read everything over here, right? So I have written from source.data loader, import load all documents. So this load all documents is nothing but this is the same function that is present inside my data loader.py. Okay. And then from source.vector store, files vector store, and RAG search I will create in the later stages. So right now I'll remove this. Okay. Now let's try to test the example. So example usage, I will write if underscore name underscore main. Okay. And then here I will go ahead and write documents is equal to load all documents, and I'll give my data folder. Okay. Data folder. Then what I can actually do is that I can just go ahead and print my docs. Okay. If you see inside this data loader, what this is returning right now, it is not returning anything. So what you can actually do is that from here, so here what we are going to do is that we are going to return the specific documents over here so that we should be able to print that particular documents over here, right? Now, what I am quickly going to do is that I will just go ahead and write open command prompt. Okay. And here I'm going to go ahead and write Python app.py. Now let's see whether it will be able to read the PDF files or not. Now here you can see it has found 4 PDF files. All the PDF file URL is over here, and you are able to see that it is also able to see all the content that is available inside that particular documents, which is good, right? And this is basically in the form of a document data structure, I guess. Yeah. So all the information is basically happening. So that basically means clearly I can see something really amazing over here is that my entire data, the PDF code that we have written is working absolutely fine. Okay. Now comes the next step. Now the next step, you should probably start thinking whether we should basically go ahead and work with embedding so that to do the chunking and all, right? So here I will go ahead and start working on embedding. Now inside my embedding, what we are going to do is that I'll be importing these libraries. Now these all are same thing repeated, but here I'm using classes and function definition. So here you can see that after reading all the documents, after loading all the documents, I'm going to use sentence transformer, recursive character text splitter. And here you can see I've defined a function class called as embedding pipeline, right? The model that I'm going to use is all mini V6 LM L6 V2. Chunk size is nothing but 1000 and chunk overlap is nothing but 200. Then here we are writing self.chunk size, self.overlap, and then we are also initializing the sentence transformer. Now in the next function that we are going to go ahead and do is nothing but we are going to go ahead and create a function which is called as chunk documents. Now inside this chunk documents, we are giving the documents, which can be a list of any documents. Here we are applying recursive character text splitter based on all these values that we have initialized. Along with this, we have also used different separators. If you're interested, other you can directly use this blank separator. Okay. Then you can see that I am also using the splitter.split documents over here. And then you will be able to see the remaining chunks over here itself. Okay. Now this is for any document that I pass inside this particular function, right? But one thing is very important is that because after the chunking is done, right, you need to also convert that chunking into vectors with the help of this particular model. So for that, I will be creating one more function which is called as embedding chunks, right? So here what I will be doing is that I'll create this particular function called as embed chunks. Here we will take this chunk. So what happens is that first the load all documents will be called, right? After that the chunk documents will be called, wherein all these documents will be chunked. Then all the chunks will be passed through our model to probably convert that into a vector embeddings, right? So here you'll be able to see self.model.encode. So show progress bar is equal to true, right? So here what we are doing, we are reading all the page content and we are performing the embeddings. And finally, we return the embeddings over here, right? So this is what we are actually doing, right? So two important function, one is chunk documents and one is embed chunks inside a class called as embedding pipeline. Now the same thing you can go ahead and test it in your app.py, right? So in the app.py, what you are going to do is that here, I will just go ahead and just a second. Let me go ahead and initialize just a second the embedding pipeline. Okay. So here what I will do, I will go ahead and write from src dot embedding import embedding pipeline, right? And once you do this, I will go ahead and initialize the embedding pipeline. Okay. And then I will just go ahead and give this, right? So this basically becomes my vectors. Sorry, embed chunks, it is there, right? So embed chunks, before that I need to chunk the documents. I also did not call the chunk documents. So let's first of all call the chunk documents over here. Okay. And then this will basically be my chunks. And finally, you can also go ahead and write over here as my chunk vectors. Chunk vectors is equal to, and here you can go ahead and use the same embedding pipeline dot embed chunks, right? And finally, you can go ahead and print the chunk vectors. So once you do this, that basically means you'll be able to understand whether the chunking is happening or not. So let's quickly run this particular file again. And now you should be able to see the chunking that may be happening over here. Okay. So it will take some amount of time because it is going to load all the documents again. Okay, and then the chunk document function is going to get applied over here. The chunk documents, what it does is that it is just going to apply recursive character text splitter on every documents that we specifically give, right? And once we do that, you'll be able to see that it is loading. You can see all the things that are happening over here. 21 PDFs, one PDF, like 21 pages PDFs is over here with respect to this proposal, load embedding, all mini models, split it. 64 documents I got into 359 chunks, and then we basically go ahead and store this. Now the next step is that after this, I will try to create a vector store, and we will try to save those embeddings also. Okay. So here you can see all the chunks is vectors are visible over here, right? So this is really, really good. So just imagine, right? In a pipeline, it is specifically working one by one, right? It is working over here, and that's the best part out here, right? Now the next step is that what I will do is that I will try to create some more functions which can be for save and load. Like if I want to save this entire chunks, how do I go ahead and save it? What do I save it? Each and every information that you'll be able to see over here. Okay. Now this was about the two important pipeline, which is basically load all documents and embedding pipelines with two important function. One is chunk documents and one is embed chunks. So guys, now the next step is that what we are going to do is that now already we have created this embedding pipeline, right? Now let me do one thing, because after performing the embedding, we also need to store it in some kind of vector store and should be persistent in any kind of directory or in cloud, right? So for this, I will start working on this vector store.py file, and here I'm going to use some code. Now you can see what all things I'm actually using. So I'm using the sentence transformer and embedding pipeline over here. Fies vector store is the class name that we are going to use. I'm going to specifically use Fies. Here we are going to use the same model, all mini L6 V2 chunk size, everything is over here. And we are also making some kind of directories, the persistent directories, like Fies store should be the name. And then here you'll be able to see I'm initializing the embedding model, sentence transformer and all. Now the first step is that build from the documents. Now see here, the same code we will go ahead and write what we had written in embedding pipeline, right? So here we are initializing embedding pipeline, model.self.embedding model, chunk size, and I've given the chunk documents, embed document, embed chunks. I've got the metadata and I'm adding all these embeddings inside my vector store. And once I use self.save, what is this self.save? Save is a function which is going to save all the vector inside this index.pickle files, right? So metadata is basically getting saved in pickle file, and files.index will basically be my vector store, which will be in the persistent directory. So that is the reason I have written files.write_index, self.index files path, right? With open meta, this and all information is there, right? So this save method is basically there. Add embedding method is over here. Add embedding is nothing but it is basically taking it. It is adding as a index flat tail 2. So these are some basic stuffs when you actually work on this. Along with that, I've also created two more function, load and search. Load and search, what it does is that it will actually allow you to load the Fies index, the vector store, okay, and will load it in the read byte mode. And then with the help of search and query, you should be able to ask any kind of queries that you have, right? You can also use this query method. Here you can see we have written self.model.encode with respect to the query test as type float 32. And with the help of query search, you will be able to get the output. Okay. So this was about my vector store. Now in the app.py, what I am actually going to do, I will just go ahead and make some changes. Okay. Now what are the changes that I will be making? Okay. Instead of calling this to, okay, I will just go ahead and write store is equal to, first of all, let me go ahead and initialize this Fies vector store. So source.embeddings Fies vector store here. Okay. And here I will go ahead and initialize this. And let me go ahead and give the path name. The path name is Fies_store. Okay. Now initially if this path is there, then it is fine. Otherwise it will go ahead and I'll just go ahead and write store.build from documents of all the docs. That's it. Now if I do this, it is just going to go ahead and for the first time, it is going to build it. Okay. It is going to build it. So let's see whether it will be able to build it or not. So here I'm going to clear the screen. Python app.py. Let's quickly see this. Now it is going to read, first of all, it is going to read it. Then this is fine. Loading, perfect. Load all the PDF files, perfect. Now the chunking will happen automatically and it will save it in the vector store inside that particular folder, that is files. Let's see. Now it is generating 359 chunks. All the steps are almost same what we have discussed from starting, but this is a very super cool way of building something, right? Now you can see save files index metadata to file store, vector store also. So here you can see file store is there, files.index and metadata.pickle, right? Now we need not run it each and every time, right? Because once we have this, right, from the next time, what we can do instead of always building, unless and until you have a new documents, I can also go ahead and write store.load. Okay. If I go ahead and write store.load, okay, I should be able to print anything that I want, right? Like, let's say I will go ahead and print something like this. I can use the same query method that we had. What is attention mechanism? Top k is equal to 3, right? So once I do this, you should be, and this time I don't think so we need to also read any kind of documents also over here, right? So I'll comment it down over here, this also. You can uncomment it if you really want to, or you can also give another conditions. Now what it will do, it will directly go ahead and read from the vector store. It will pick it from the persistent directory and it will give you the output. Let's see. So from the file store, it will go ahead and pick it up. And here you go. Here you get the answer clearly, right? See, loading embedding models. This is there. Loading files index and metadata. What is attention mechanism? All the information is over here. And this is the output that you are able to get, right? Perfect. This is what exactly I was actually talking about. But the best part is that you have created this in the form of a pipeline. You have data loader, you have embedding, you have vector store. Now for search, what you can do is that you can integrate any LLMs over here, right? So for this also, I have written the code. Again, I don't want to discuss it step by step, line by line, so that it will be again taking a lot amount of time to complete this, right? So here I have my load underscore dot env. You can just go ahead and load all these things. Grok API key is given over here. You can use it, or you can use your own Grok API key. It's fine. Okay. And then we are doing this search, right? Wherein we are using this vector store dot query, getting all the documents, getting all the metadata, and then we are giving some prompt and we are invoking it along with the LLM. So once we do this, it is superbly easy to execute this. Anyhow, you can do the research because I have discussed all these things in my Jupyter notebook, right? Now what I will do in my app.py, I'll see what changes needed to be added. And what I will do is that I will first of all import RAG search. Again, from search, import RAG search. And then I will go ahead and initialize like this, right? And now I don't even require this. Okay. Now let's see whether it will be able to give the summary or not. It is loading from the vector store. Now I'm asking the question, search and summarize is the function. Here what we do, we first of all do the query from the vector store that we were usually doing before. Then we give a prompt and then finally LLM will be able to give the output. So here you can see if my LLM is fine, then I think I should be able to get an answer. So here you can see all the output is basically over here. So this was a complete idea or a kind of crash course that I really wanted to give on the entire RAG. RAG is one of the most important use cases. That is what I always believe. Most of the companies are specifically building RAG applications. So I think this is really, really important and super cool topic. I hope you like this particular video. This was it from my side. I'll see you in the next video. Thank you. Take care.